Welcome to the monthly webinar series. This is the May 19, 2022 webinar that we're going to be doing on automotive testing, and we'll be getting into that here in just a moment, but we'll do a quick company overview here. So we have been in business for about 27 years, started in 1995 by John Van Baren. Phil Van Baren soon afterwards came on board and continued Vibration Research's success with continuing to upgrade the hardware and the software here at Vibration Research, and we have been enjoying that hardware and software platform that we continue to make bigger, better, faster with every iteration that we come out with newer hardware and newer software to keep up and continue to assist in changing the vibration testing world for the better. It is always our goal. We have offices throughout the world, but most of what we do here for hardware and software development is done at our USA headquarters in Jenison, Michigan, just outside of Grand Rapids, Michigan. We have a number of other sales and support offices around the world in the United Kingdom, in India, and in Germany, in Czech Republic, and China. And they're also able and willing to be able to help you with any support and sales related questions as you go through the journey of selecting a shaker, controller, or data acquisition device. Many representatives for Vibration Research also exist throughout the world, and they also can give you a certain level of support as well, and we also assist them in that, and in that network able to assist our customers as much as we can. Taking a look at some of the testing industries that we primarily work in: aerospace, automotive, which is what we're going to be talking about today, electronics, military, medical, packaging, seismic, transportation, watercraft, and much more that are being done and developed for making products better, making them last longer when they get into the field, and making warranty claims go down, which is typically the goals of the different manufacturers and the suppliers for the manufacturers. Here's a few of the customers that Vibration Research has. You can see we have some of the tier 1 suppliers for the different automotive manufacturers that we'll be talking about today, like Gentex, Continental, but then you look at the automotive manufacturers like BMW or Ford or General Motors. Many of these are doing vibration testing and doing that to make their products as durable as possible and last as long as possible. Be getting into that in a moment. These are the core values that we always strive for at Vibration Research, trying to always be collaborative in our interaction with each other, but also with our customers. Always be thought of as capable and competent, so we strive to continue in our education, each one of us here at Vibration Research, and then holding each other accountable and responsible for decisions that we make. Strong and driven work ethic so that we are always able to help each other out in different areas when we are busy. Do the right thing is a pillar also for Vibration Research, and then we want to continue to push innovation in this specific field, so that's also something we strive for, and you see that coming out in a lot of the hardware, but especially in the software features that we come out with. So this is the innovation process that we've gone through at Vibration Research over the 27 years we've been in existence. In 1995, we started with field data replication, where we can primarily just record data and replay it one-to-one, and get that same event that you recorded in the field and run that back on a shaker system. And that's a non-iterative approach, so we can read a 4-hour recording and start and get up to level in seconds rather than playing through the data many times. Kurtosion is another aspect of random distribution for a specific random waveform that you'd be running. I'm not going to go into detail on all of these, but these are just kind of walking through some of the innovations that we've gone through. There's specific webinars that I'll run through here in just a moment that we can look at too for each one of these. Fatigue damage spectrum takes recorded data like you would use and record on field data replication, but it randomizes that data looking at fatigue from the real world and creates a random test based off of that. Instant degrees of freedom also takes the ability to get your smoothest lines in the industry and be able to have as close to realistic random testing as possible. So we're able to look at output versus input and get that data graphed in real time so you can see ahead of time if something's going to be in or out of tolerance before being at full level. And then sign tracking analysis and generation, or STAG as we refer to it here, where we can pull out the random background and run sign tones in a specific way, so you can also have a more realistic test as well. So that's kind of our goal in all of these, is to get as real world and realistic tests as possible. And then we're always continuing to push forward into the next innovation. That's always our goal here at Vibration Research as well. Before I move on, I just want to quick open this up on the website. I talked about other webinars. If you go to our resources page here, click on webinars. This is where all our other webinars are located. So you can see FDS is here, creating test profiles, IDOF, that's what we were talking about earlier, kurtosis control. These are all in here as well. And you can look at those. There's a long history of all of our different webinars in here as well. Here's the STAG test generation here as well. One other thing that we'll run through is on vibrationresearch.com homepage is the download free software demo. So the exact same software that you can be used connected to a controller can be used at your desk or on your laptop. It's the same software and you can run in simulation mode. And you'll be able to enter all the same profiles and specifications that we're going to do today, and take a look at those, and you can verify that your test can run before you bring it to the shaker. So you can tell a customer if you can run a test. You can use our software to determine if your shaker is capable of doing that. You can use it to create reports after you're done with it. So you can take data from the shaker and take it back to your desk with simulation mode and create reports as well. So that was the main things I wanted to show on the website. Here's a little bit about the hardware that we produce here at Vibration Research. We have the Observer 1000 platform. This is our fully autonomous data acquisition device. It has a battery inside and emits its own ad hoc Wi-Fi network so that you can connect to it and take control of it remotely with your cell phone, or you can just push the top buttons here to get my mouse up. You can push these top buttons to start and stop the recording here as well. It can stream it to an SD card on the backside, or you can connect it to your PC or your laptop via an Ethernet connection, and you can stream the data to disk that way as well. And that runs on our, the analysis for that can be done typically in our ObserveView platform, which is another module or software platform that you can download when you hit the download demo button on our website. But I'll be specifically really be looking at the VibrationVIEW platform because we're going to be running some tests. And the VibrationVIEW platform is run with VR9500. This is the lower channel count, lower sample rates than we have had, and we've upped that since we have the VR10500. So you can go up to 128 channels with a 9500 and 512 channels with a 10500 platform currently. So that's the difference between these two. And then we have a small line of shakers, 600 horsepower on down, that can also help for a small shaker size setup. So these are the different software platform modules that we have. We'll be primarily working in sine and random today. That's a big part of the specification world out there for the automotive testing, vibration testing specifically for that realm of the testing world is sine and random. And then we won't get much into field data replication or the fatigue damage spectrum, but those also exist there. Sign on sign is one that we've seen a few times up and coming in automotive world. There's some BMW specifications out there too that have you do multiple sine tones at the same time, and that's a module that you could use as well for those type of specifications. So yeah, we're going to get right into it now that we're done with our overview. I am Jordan Van Baeren. I've been at Vibration Research for 17 years now. 2005, had to do some math. Hopefully that's right. And been in the lab, done sales and training, and yeah, continuing to do that and help support customers as well along the way. And it's always fun to go meet new people and see new applications. All right, so we're here to talk about the automotive testing world, and we've had an evolution in cars since cars came to be, going from steam engine to gas, diesel, hybrid, and having electric cars out there, and then everything kind of in between this world right now. As we have more and more different models coming out with electric or hybrid, and then other ones that are being produced or made in the internal combustion area. All of these types of vehicles need to be tested to make sure that they're able, as changes are made in the car, to make sure they're going to work when they get to the real world, so that the warranty claims are down, those types of things. And we continue to make then our hardware and software better in the vibration testing world, because this is kind of how we did things in the past, where you had a van that would follow a vehicle that was being tested. You had all the cables going back in here and racks of data acquisition device inside this van, taking the data and streaming it analog to disk inside here. So all the sensors would come back in here. This is cars driving around a track to get some real world data. This one's on a cobblestone track, and seeing what that vehicle would do once it hits that type of road in the real world. And then we kind of make then the push to this type of thing, where you have an autonomous device that you could put right in the car, taking that data and do the analysis and creating test profiles based off of some of the data that you take from a vehicle, and run that on a shaker system with the controllers. All right, so this is what some of the automotive companies that we'll be looking at today, but a couple of specs that we'll see from a couple of these companies that they're using. But many auto manufacturers and there's tier one suppliers are doing that because there's a testing standard that that they've made or that they're using from the industry, whether that's the MIL standard or some GMW spec or some other type of standard or specification that has come out, or they're trying to make their products better for market, and they're creating their own standard or their own specification for what they're seeing their product needing to be able to withstand when the product gets to the real world. And then they're trying to do this so that the products last longer and the warranty claims go down and the product looks better after it's been in the real world for a time. And then we'll be looking at this too as we look at whole vehicle to component. You're doing a vibration testing on just a component like a seat belt, or you're doing it on the whole structure, maybe the whole seat with the seat belt included in it, or you're doing all the way to the whole vehicle, like it says there, and you put the whole vehicle on a shaker and doing testing in that manner. So everything in between is then done, from whole vehicle all the way down to individual component, depending on where that company maybe fits in the line of supplying an automotive manufacturer. So if you look at Gentex, for instance, they would be making maybe the mirrors, rear view mirrors for the car. They need their different types of specifications and profiles for the different vehicles that they're putting their platform on, and those are going to be vibration tested differently depending on the type of make and model of the vehicle. So a couple of different shaker types that we'll be looking at when we run different types of vibration tests. Electrodynamic is a pretty common type of shaker to use. You have a high frequency with low displacement, so you can go many thousands of hertz. Typically you're running 2,000 or more hertz on an electrodynamic shaker, up to 6, 8, 10 kilohertz depending on the shakers, maybe a little more in some cases, but those are pretty small usually. But they're lower displacement. The highest displacement you typically get is like 1 or 2 inches out of an electrodynamic shaker, and you can get up to more than that. There are a few manufacturers getting 3 or 4 inches on the long stroke shakers. I've seen coming out too. That's a neat addition to the industry as well. But those can be expensive, and maybe with the higher displacement, you don't typically need the high frequency also. So some people then will opt for servo hydraulic. A servo hydraulic shaker like this one here is going to be doing lower frequencies for higher displacement. So when you're talking, a half a hertz, and doing that at a couple G's, you're talking many inches of displacement, and you can do that on a servo hydraulic shaker. The drawback of that is you're typically running maybe 250 to 350 hertz max. Sometimes in certain applications you can get upwards of maybe 500, but typically you're running, let's say, 350 or less in hertz on a servo hydraulic type application. And I'll be talking to a couple of industry experts at the end of this webinar that I had recorded a phone call with each one of them. That I talked to them yesterday, going through a couple of applications, each one of them talking about electrodynamic shaker, and the other one kind of talking about some of the testing they're doing on a servo hydraulic type application. All right, so here's some of the other types of tests. I talk about buzz, squeak, and rattle test. Here's an individual component. This is a seat belt being tested on a shaker, and then they're listening for that buzz, squeak, and rattle with a microphone. So that's one of the types of sensors that you would use. Well, you have an accelerometer, maybe putting road load profile into the shaker here and feeding that back to the controllers for that closed loop testing. The microphone is listening for, while the road profile is being played on the shaker, listening for buzz, squeaks, and rattles as this particular component is mounted and run through the road profile. So that's an individual component, but like we looked at here, you can see the whole seat assembly with the seat belt is mounted to the shaker, so you can do whole components instead of just an individual component. You could do it with the whole seat there. You need obviously a larger shaker for that, or in this case, you do the whole car, and that is another method of doing that, but that's an even larger shaker. And depending on where you are in creating some of these profiles, you might be able to only need a small shaker or something much larger. We're also looking at some of the changes in the industry are some of the multi-axis testing for running the simultaneous multi-axis. So you could do X, Y, and Z all at the same time. And that also will give you something more realistic. That can be a big push as well. I've been seeing some more and more specifications on that. Typically seeing a lot of, majority of the specs that I've seen and talking to others and other customers, it's a lot of single axis specifications, but that has been a push by some of the manufacturers on down, is to get more tri-axis or multi-axis testing with X, Y, and Z on shaker systems, but those are really big shakers typically. This isn't necessarily the same type that you'd use. This is a really more a seismic application, but you could do X, Y, and Z on this type of setup as well. You can do that with an electrodynamic type setup where you have X, Y, and Z, and there's a few manufacturers out there that do that as well. All right, so here I just have a list of a couple of transducers that I wanted to make sure we take a look at. Majority of what we're looking at are accelerometers when we're doing these tests. Accelerometers, majority of what we see are IEPE or ICP type sensors, where we provide up to a 4 milliamp signal with our controller to power the sensor, and then those, a lot of times we can use those, and they run with TEDS, the transducer electronic data sheet, where it has the birth certificate of the sensor built into the accelerometer. Charge type sensors are also something you can hook up to the controller of the 9500 and the VR10500. You will need to supply power to that, externally condition that signal. But there are some charge barrels you can use in that case, and sometimes that can be necessary. And most times when you're using charge type sensors, people are doing shake and bake testing, where they have temperature ranges that are going above 275 degrees Fahrenheit, because many of the IEPE type sensors that I've seen, that's usually the standard, they'll go there. Some IEPE type sensors can go higher than that as well, but that's one of the neat avenues that people, where they'll like to use charge mode, but that's a pretty small piece of the market, but is still something necessary when you go to those high temperatures. Strain gauges are often used and hooked up to equipment while you're running through vibration profiles to see where the device under test has different strain values throughout the profile. Pressure transducers, that is something set up that you look at maybe something under pressure while you're running a vibration profile. Seen that on different gas tanks, for instance, while you're running a vibration profile, or a recording one-to-one that you've seen in the real world. Monitoring the pressure of the tank until it maybe falls below a certain PSI. You can take a look at that and make sure that you stop the test once the gas tank goes below a certain PSI. A lot of people also like to look at straight voltage. We'll take a look at one of the specifications with voltage, because there's so much electronics in a car now. There's a lot of specifications out there for monitoring voltage. Well, there's a vibration profile going on, and you can monitor directly into the inputs of the 95 and 10500 straight voltage, because that's really what you're looking at, is change in voltage when you're looking at any of these types of sensors. You just have to scale that appropriately in the software to millivolts per G, or millivolts per Pascal, or millivolts per volt, even in the case of voltage. Laser vibrometers can be a very nice use. There's a very nice use case for those too. If you have a piece of equipment that is not able to be hooked up, have a sensor hooked up to it, because maybe it's hard to apply a sensor there, or maybe you don't want to add any more weight to the product there, you can use a laser vibrometer to accurately see what's happening on that sensor, and see the deflection quickly, and analyze that data then as well with a laser vibrometer without adding weight to the device under test. Thermocouple also is used as well. That can then view the temperature of the device under test, or some other piece of equipment in the test. There's lots of other types of transducers that could be used. These are just some of the more common ones when we were talking vibration testing in the automotive testing world. These are probably the most common types of sensors that we see. We're going to take a look at, in just a second here, a few of the standards as well. Lots of different testing standards out there. We'll take a look at a few of these. The MIL-STD-810H is the most recent MIL standard. A lot of auto manufacturers and the tier 1 suppliers follow some specific sections of the MIL-STD-810 for some of their standards that they want their products to pass on. And there's been some changes to the MIL-STD-810H, especially when we look at shock tests. There's a few of those too that are also, we've made some changes to the 2021 version of the software. last year that also follow some of those changes that you can use in that most recent release of the 2021 software. And we're in 2022 version of VibrationVIEW right now. Then there's the SAE J1211. That one is also another SAE standard. The GMW 3172 is a specific standard that General Motors puts out. ASTM series is another version of testing that is done by an organization as well that has many different test specifications inside of it that many auto manufacturers follow. The EV standards are new recently to the industry that we didn't really have before for electric vehicles. The SAE J2464 and the IEC 62660 are standards that are used for specifically used for EV electric vehicles, and those standards are also something that can be used in the VibrationVIEW software as well. And that is the test running. We had this in slow motion, so you can kind of see that resonant frequency running, but I had embedded that video in there, and you can kind of see that live running on the shaker as the product deflects under vibration at resonance. All right, so these are some of the software modules that are commonly used in vibration testing in the automotive world. We'll be primarily focusing on sine and random. Those are the, encompassing probably 80+% of the testing that you do in the automotive world. There's other ones that we take a look at. I mentioned earlier, like sine on sine with some of the testing standards, specifically out of with BMW. I've seen those quite prevalent there. But majority of what we see is sine and random, and I'm going to enter a few test specs for that. So we're just doing one frequency at a time, and you can find resonance, a resonant frequency of your product to see if that's going to be affected in the real world. You can excite many frequencies at the same time. So that's good for seeing what's happening to your product, because your product's not going to see just one frequency at a time. So you can hit it with a whole bandwidth of energy at the same time, because that's what it's going to see when you go to real world. And then there's drop or bump tests, these shock replications that you can do to your product. Hit it with maybe a half sine pulse with 11 milliseconds wide, 10 Gs or something like that. And those are also common in the industry. It has to be able to withstand many different shock pulses to replicate different events that the product can see. Field data replication is something that is also seen in running that back on the shaker 1-to-1, and fatigue damage spectrum takes that recording that you would use in field data replication, FDR, and runs it in FDS in a randomized way, looking at fatigue that you saw in the real world and getting that back in a random test. So I'm not going to spend as much time on those last three, but those are just some of the use cases of software that are also used in the vibration testing world here for automotive. But we'll look at a couple of standards for sine and random here. All right, so this is a specification from an auto manufacturer, and I think this one has 6 different classifications, and usually you're going to have a couple of let me make this a little bigger on mine. What you're going to have is the classification given to you by the manufacturer, and you have to say that, okay, I need to be able to pass classification 1, vibration method A, and this is maybe a mild, where the product is going to be mounted is going to be on the body away from the suspension attachment point. So then you can kind of figure that out. Okay, this is going to be here, and I need to do vibration method A. Typically that type of standard is going to be given to you, and I'm going to run through how to enter this specific test profile in the software right here. So let's enter a couple of these here a second. All right, so what the test profile said to do was, let me just make this a little bigger here. Zoom in, here we go. All right, so new test. Again, I'm in VibrationVIEW 22.1 software, and you can download this and use it yourself. If you go to hardware, you can just use demonstration mode. It's the same software that you'd use connected to a 10500 or a 9500. But use demonstration mode. I encourage everyone to get on and use that as well. So, new test, and I click sign. And so here is my test, and this is what's called quick test mode. For this test, I'm going to show you how to enter it in advanced mode. I'll come back and show you something in quick test mode here in just a moment. When I go to advanced test, I'm going to go back to the profile tab, and I'm going to look at entering this test in, I have 10 millimeters peak to peak. So it's got displacement in peak to peak, which is how we have this in the software, is peak to peak. But the low frequency here from 5 to 15 hertz is displacement limited. So it's telling us 10 millimeters peak to peak is what that software is going to be running from 5 to 15 hertz. So I can do this because I'm going to be going to acceleration next, but I can do this all in the same profile. You can see I have G's, inches peak, inches per second, and inches. So that's acceleration, velocity, and displacement. Right now it's in inches, but I can change my unit. Yep, create advanced test. I can change my displacement units here. Instead of in inches, I'll change this to millimeters because that's what this specification is here, is millimeters, 10 millimeters. So I changed this to displacement instead of acceleration, and it's 10 millimeters at 5 hertz to 10 millimeters at 15 hertz. Insert. And then I have and 20. So then I'm going to go here and say, all right, now I'm going to 4.6 Gs. I'm sorry, 4.5 Gs. Change that 4.5. At to 25 hertz. So we're going to go out to. So it also, the software gives me this little calc button here. So it's telling me, hey, there's a little bit of a discrepancy probably between where the crossover point is at 15 hertz. The specification was probably written with, hey, 10 millimeters is approximately 15 hertz, where it changes from 10 millimeters to 4.5 Gs is almost exactly at 15 hertz. But if I hit the calc button, it's actually calculating at 14.95 hertz, and I can either accept that value so that it's a smooth transition here when we go from displacement to acceleration, or I can just leave it at the 15 hertz. I'm going to say yes because I like to be very specific, and now I'm at 14.95 and 14.95 here. That's where that transition of 10 millimeters matches 14.5 Gs, or I'm sorry, 4.5 Gs. I hit insert 2 more times because I've got 2 more lines to put in here. So 25 hertz and 25 to 100 and 100 to 200 is my profile that I need to put in here. This one is going from 4.5 Gs down to 2 Gs for this higher frequency range. So it's kind of stepping this down. And then the last part is at 100 to 200 is 0.5 Gs. So I'll just type in 0.5, 0.5. And now I have this profile entered. So I'm doing this sine sweep. It's controlling on displacement. If I change this here, look at displacement, you can see displacement's flat. And then it kind of goes down, steps down, slowly brings down displacement, but it's holding fast here. You can see acceleration is constant. It's just stepping that down. So that's what we just entered in for this profile with the classification number 1 description here in vibration method A, and we did this this profile. One other thing on this profile is, let's see, time per sweep in minutes is 20 minutes per sweep. So that can be pulled in here in the sweep tab. This is a pretty slow sweep, but if I go to the sweep tab, I can do minutes per sweep. And it's 20 minutes per sweep. And what VibrationVIEW looks at as a sweep is going from this low to the high. That's one sweep. If you need to go from the low to the high back down to low, we would call that 2 sweeps. All right, so time per sweep is 20 minutes per sweep. If I look at my schedule tab, it says 20 minutes here, that is going to take this test to run because I'm saying I need to do one sweep, but it says number of sweeps per axis. I need to do 18 of them. So if I put in 18 here, it says it's going to take 6 hours to do 18 sweeps of 20 minutes from 5 to 200. That's and then back down is another sweep, but it's going to take 6 hours to accomplish this one. If I go over here a little bit, it says the whole test is going to take 18 hours, which makes sense because it is, I need to do this for each axis. So X, Y, and Z. So I would need 6 hours to accomplish X, and turn the product, do Z or X, and then X, Y, and Z, 6 hours each. So that's 18 hours. All right, so give that test a name and it's ready to go. And then it has my profile name of my test in the bottom of the software here as well. So every time I enter another test, it shows up in the tab form here. All right, so the next test we want to take a look at is, bring this one up. This is the MIL standard 202G. This is for electronic components that go in a car. And there's so much electronics going into cars nowadays, and has been for quite a while, but it continues to be more and more. This is we can look at test condition B on the graph here. It's really some of the same stuff. You just have to kind of look and define how some of the acceleration levels are done off the graph here. But we're looking at test condition B, and we have an amplitude of 0.06 inches peak to peak, or 15 Gs, whichever is less. So this is another sign test I want to take a look at. The reason I'm looking at this one is because we're going to run this one in simple mode. So I can just show you a quick way to, when you get a test specification that says 0.06 inches peak to peak, or 15 Gs, whichever is less, there's an easy way to accomplish this in the software. All right, so new test, click on sign again, and I'm going to stay in quick test mode. And this was, let me look at this, 0.06, so 10 to 2000. There we go. 10, 2000. And then it told us to 0.06 inches or 15 Gs. So let's enter that. Displacement of 0.06 inches peak to peak, or 15 Gs. So I'll type that in here as well. And now you can see the software automatically calculates this point, kind of like where we were clicking the calc button. The software's automatically doing that for us here. So I have 10 to 2000 hertz and 0.06 inches peak to peak and 15 Gs. And the software is going to do whatever it needs to do to make that work. So if I go back and look at the profile tab, I can see it automatically did this calculate of 69.9 hertz. And that's where that crossover point is. So the software's doing some of that automatically for you. All right, so that's a little piece of that standard. Let's look at another one, and this one time we're going to take a look at random. This random test is one I like to look at. Many of you have seen this one. Maybe many of you have run this one, the NavMat test, the haystack, as sometimes it's referred to. Get all the energy really here in the midsection of the vibration profile, 80 to 350 hertz. But what's unique about this profile is it gives you 4 frequencies, 20, 80, 350, 2000. but it only gives you 2 amplitudes, which is not as common for vibration profiles. Typically, people who make vibration profiles like to throw some tricks in there usually, I kind of feel. And this is one of them where you need to have this calculated. They give you the slope though to calculate this value here, but the amplitude is known and the slope is known for both sides of the top and bottom frequency. So we can calculate that. So I'm going to show you how to do that in the software. But remember, we're going to make sure that we're going to run this with just over 6 G's RMS on the test that we're creating. So let's go back in here, click New Test, Random, and I'm going to do this in advanced mode. So I say 20, 80, 350, 2000. We know that this was 0.04 at 80 and it was 0.04 at 350. This is where it starts to get interesting. So we know these values, all 4 frequencies, and we know these 2 amplitudes. So what you can do in the software is we can calculate this value here. If I first click in this known value, then in this known value, you can see that this turns yellow. It says, hey, because you clicked that way, we're going to calculate what this is going to be. So the software is ready to calculate that, and we know that this from the spec was 3 dB per octave. I can hit the tab button and click out, or check, or just click outside the box, and it gives me what this calculated amplitude is if at 80 hertz is 0.04 and the slope between 20 and 80 is 3 dB per octave. This is 0.0100475. So you can kind of see why they made the spec this way, because this is an easy value to write of 3 dB. And this would be kind of cumbersome to put in the spec. So I'll do that again. Click in my first known value at 350. Second known value for the slope is a -3. And I'll hit the tab button outside there and I get this long significant digits, 0.00704,187 G squared per hertz. And now I have a GRMS of 6.06. And that is what we were looking for here, was 6.06 G's RMS. So that is the NavMat test ready to run. All right, so one more neat feature I'll show you. In the VibrationVIEW software, I've seen a lot of specifications in the automotive industry where they'll have the specification that might be coming from a road load profile. Or it's just a profile with lots of breakpoints. Frequencies and amplitudes come in an Excel sheet or some other type of PDF. And there's a really nice way that you can pull some of those in without entering some of those in the software incorrectly, because you could have significant digits way out here. But I'll just show you this. This is a specification that I had received. I can just right click, or let me show you again. I'm highlighting just the frequencies and amplitudes that I want to pull in the software, and I right click in Excel and say copy. Go into VibrationVIEW. Anywhere inside this white space of my breakpoint table, if I right click and say paste table from clipboard, again, I'm right clicking in this white space here of an advanced test, and I say paste table from clipboard, create advanced test. Yep. Are you sure you're going to get rid of all these other segments that you put in there? And I'll say okay. And then it automatically pulls those in. So this should be 7.6 G's RMS, and I have 7.6 G's RMS in here too, then from my test profile. So it's ready to run this test now as well. But you could have, actually here's where it was, 7.62 G's RMS. And then you're ready to run. This could be hundreds of breakpoints long, and you just highlight it, copy it, paste it right into the white space of an advanced random test in VibrationVIEW, and you're ready to run. Some of the up and coming things that you do also see, I'm not going to run into this into too much detail because we have a whole webinar on going field to lab with some of your data. But if you want to create a random test based off a recording, you can do that too in the VibrationVIEW software. Let me just hit cancel a second and show you that briefly, but there's a whole webinar that goes into this too. Fatigue damage spectrum. Look for your recording. This is a recording of an accelerator stomp, hitting the gas on the car and going. You open that up, it pulls this in, and you say, okay, I want to run this test. I want an equivalent of 10,000 hours. I want to run that in 100 hours on a shaker, and then you can create a table, and then it's ready to run this profile. If you go to the table tab, it's got that table automatically pulled in there, way down here. Schedule tab already has this in here ready to run for 100 hours. So that's a quick look. There's a whole bunch of stuff that you can do and make changes and analyze and filter data in the webinar that talks about going field to lab, but that's another application that you can do in the software. All right. So the next step I wanted to take a look at is run through and talk to a couple of experts in the automotive testing field. And I reached out to a couple of people that we work with to get some of their comments on some of the things that they see in the automotive vibration testing world. And I wanted to run through that. I hope this will work in this manner so you'll be able to hear it. I might have to use my backup way to make this work, but bear with me here just a moment. All right, so I am talking with Eric Lindberg of Elite Electronics out of the greater Chicago area, and wanted to get his expertise on a couple of things as we discuss all things automotive testing, vibration testing specifically. So welcome, Eric. Thank you for coming.
Yep, thanks for having me.
All right, so what sensors do you typically use in your vibration testing setups?
We typically, and it kind of varies on job to job and depending on what customers request, but typically we use the Dytran 3056 control accelerometers, and then we throw a response on there. More recently, it's been a lot of Triax accels.
Okay. And then these are IEPE type accelerometers.
Correct. Yep.
Okay. And then are you using then TEDs on those, the transducer electronic data sheet on a lot of that?
We actually do not. We just use the VibrationVIEW database.
Oh,
and
gotcha.
Then my technicians can then just type in serial number and it just populates what they need to.
Good deal.
So it kind of takes the thinking out of it as well, just kind of like TEDs.
Yep. No, very good. Another question, what changes have you noticed in the vibration testing industry?
There has been a lot of changes that I've seen. Changes in temperature profiles, changes in vibration, G levels that we're seeing. And then I think one of the biggest changes is payload. I think we're running much bigger items that require a lot more payload for shaker capabilities, all while keeping the main levels that we're trying to reach. So I think payload would be a big one.
Gotcha. And does that kind of come from maybe doing a lot more component level testing in the past, and now they want it done more on a like that component mounted with the whole area that it's going to be mounted to and tested all at the same time now?
Yeah, so we're and fixture design is playing another big role in this, and that it's not just bolt the product down to a flat plate anymore. They actually want it in a vehicle orientation, and that's getting a little more strict. And so with that being said, the fixtures are becoming a larger size fixture to house, a headlight or a light bar or even a battery that we're starting to see.
Gotcha. Very good. Another question. Do you see shake and bake testing as becoming a little more normal, or is it more common to kind of keep them separate when you do the temperature and the vibration together, or are you seeing it a little more common separate?
It's actually it's probably been the same for us here at Elite, but it seems that a majority of our automotive vibration testing coming through does require temperature, and so then we have to adapt our fixtures to our head expanders and G10 to seal chambers over. So I guess yes, probably a increase has been seen recently.
Okay.
To do combined environment.
Very good. Well, last question, probably most important, though I've been asking also, is what is your favorite ice cream that you're going to be having this summer?
So I am not an ice cream guy. I like raspberry sherbet.
Oh, that's some good stuff too. I'll accept that answer also.
Awesome.
All right, so that was, again, Eric Lindberg at Elite Electronic, and thanks, Eric, for coming on that for that portion and giving that wisdom as an expert in the all things vibration testing for automotive. I also talked with Dave out of MGA. Dave Maroney has been in vibration testing in automotive industry for quite a while, and talked to him as one of the experts in the industry also. And here was my conversation with him for a couple minutes. Thanks for coming on, Dave.
Hey, no problem at all, Jordan. Anything for you guys.
So first question, what are the most common test types or specs that you guys run?
Right now, being in South Carolina, we're in direct work with BMW out of Greer.
Mm-hmm.
So I run a lot of the BMW specs. The biggest ones that I run would be the PR309 and the 311. It's a vibration with a BSR test in there.
Gotcha.
Yeah, that happens to be the biggest down here. That's like our bread and butter here. Coming out of Michigan, I was a lot more on the BMW or the GM side.
Mm-hmm.
GMW 17010 was the biggest one I ran because my focus was always on engine components for GM, and that falls under that spec.
Yes. Got it. Nope, makes sense.
Yeah.
So then what type of frequencies do you typically run with either that spec or some of the other ones? You have some, I'm sure, a wide range of capabilities there, but what's some of the most common specifications or frequencies that you're running in those specifications?
Yeah, most commonly we go down to about 5 hertz as our low end. We like to set that, and I know we can do like the 3 and 4s if the amplitude's not too bad, or the displacement,
mm-hmm.
but generally like to stay around the 5 hertz. And we, on average, we go up on average to 200, 250.
Okay.
We like to cut it off there. If you haven't hit a resonance by then, then your part's probably usually okay.
Okay. Pretty neat. What kind of difficulties is most common that you're overcoming when running some of these tests?
The 60 cycle noise.
Okay, so dealing with some grounding loops or something like that.
Yeah, the ground loop is always a nightmare for me. I think we had something from you guys sent to me in Michigan, a DIN box.
Okay.
I could be wrong. I'm not 100%. This was years ago. I had just installed one anyway on my shaker, and it seemed to help.
Okay, took that 60 hertz noise away.
Yeah, it cut it down about 70%.
Okay.
And then we 3D printed blocks here out of like a carbon material for isolation on the Excels.
Got it.
That helped the rest of the way.
Okay, got it. A little more isolation. Nice.
Right.
Then last, but most important question, favorite ice cream that you're going to be having this summer?
Oh, man, I'm such a basic guy. It's just vanilla.
Okay. Vanilla all day. Love it.
I can't step away from it.
All right. I love it. Good. Well, I appreciate it. Thanks a lot for your time, Dave. All right. So that was a couple of the guys I had talked to in the automotive testing world, and yeah, thank them for their time as well. So yeah, that's kind of the end of today's presentation for automotive testing and vibration testing specifically on that. If you have some specific questions, we'll stick around here for a little bit. And as always, though, call us 616-669-3028, email vrsales@vibrationresearch.com, or if you have a support question, send it to support@vibrationresearch.com, and we're standing by always to help or assist people as we can. So thanks everyone for your time, and have a great rest of your day.